Okay, question 21, show that. So I'm taking the left-hand side. I'm ignoring the right-hand side for now. It's like a proof question. And that's what my final answer is headed towards. So I start with root 45, add root 20, and the final line when I get there eventually is going to be 5 root 5. Okay, so root 45 plus root 20. Simplify these fractions as far as you can. Find nice whole square numbers that go into 45 and 20. So I know that 9 goes into 45, the highest square number. So root 45 can be rewritten as the square root of 9 times 5 inside, which you can simplify out as the square root of 9 and the square root of 5. Similarly, for the square root of 20, the highest square number that goes into 20 is 4. So you can rewrite 20 as the square root of 4 times the square root of 5. Root 9 is 3 and root 4 is 2. So you've actually got 3 root 5 plus 2 root 5, which added together makes 5 root 5, which is what we would have shown in the first place is the answer. So that's a proof, that's a show that question. Second one. Okay, so we've got a irrational denominator. The one on the bottom looks got a square root in it. We're trying to get rid of that. Now what you do is you multiply the top and bottom by the same number. That number happens to be the same as this one here where you change the sign in the middle. So you're timesing it all by the top and bottom, look, root 3 plus 1. 2 lots of that on the top makes 2 root 3 plus 2. On the bottom, root 3 times root 3 is root 9. Minus 1 times plus 1 is minus 1. And if you were to times 1 by minus 3 and also minus 1 by 3, they would cancel with each other, so you can ignore those. 2 root 3 plus 2 on the top. Root 9 cancels to be 3, take away 1, which is 2 on the bottom. Divide through by the top. So divide through the top by the bottom, and you end up with root 3 plus 1. Okay. Final one, express that in the form, this one here, look, that's called completing the square. X plus something squared plus number. Now, when you complete the square with an x at the front, you need to half whatever this number is in front of the x. So in this case, look, in front of the x, I've got 6 root 2. So in the bracket with the x is going to go plus 3 root 2. Half it and it goes in there, squared. That's how you start complete the square. Now, if you were to square this out, you would get x squared plus 2 lots of these 2 times together plus this bit squared. Now, I don't want this bit squared, so at this stage, I'm going to say, right, I'm going to take away the 3 root 2 squared, whatever it is, but I do want the minus 1 on the end, so I need to put a minus 1 as well. Okay, so this will multiply out to be what I want when I take away the 3 root 3 squared. Simplifying this bit here, you square the 3 and you square the root 2, you get 9 times 2, which is 18, minus 1 more, x plus 3 root 2 squared minus 19. All right, completing the square.